Differentiation from first principle of y equals x square. So all the differentiation result can be found out using the first principle. We'll take an example of y equals x square. Now the differentiation of y equals x square is 2x. This is 2x. From where it has come? How did we get this 2x? Now the same concept we'll do. In order to find out the differentiation, we have to find out the tangent on that point of the curve. So y equals x square. So if x is x, then y will be x square, because y is x square. So x1, y1 we are not writing. We are writing x as x, and y is, because y is equal to x square, so y will be x square. Now we are saying that we will try to have a point B which is very close to A, and finally we'll try to make A and B together, that is coinciding one another, because we want tangent. Remember, we don't want a chord. So we are just adding a small value, x plus delta x. We are just, when we take x plus delta x, the y will be y is equal to x square. So it will be x plus delta x whole square. Okay. So one is x, the other is x square. When you add x plus delta x, the other value will be x plus delta x whole square, because y is equal to x square, which we are finding. Now first let us find out the gradient of the chord. Because 2 points are there, it is easy. y2 minus y1, x2 minus x1. This is the gradient of the chord. Remember, we are not interested in the chord. We are interested in the tangent. So y2 minus y1 by x2 minus x1. What is this? X plus delta x whole square minus x square divided by x plus delta x minus x. This is a plus b whole square, a square plus b square plus 2ab minus x square divided by whatever is this. It means x2 minus x1. Just cancel these two xx. Okay. So y2 minus y1 we have taken in the numerator, denominator we have taken x2 minus x1. I hope you got the idea. So del x del y is very, very small. We'll make it smaller by putting del x as tending to 0, limit. Now cancel this x square, the denominator also xx will get cancelled. Del x you can take common from the numerator, del x plus 2x will be inside, del x you can cancel. Del x plus 2x will remain. But what did I tell you? We are not interested in these 2 points. We are trying to find out the 2 points together. We want a tangent. So ultimately A and B has to be together. For that, what we have to do, this delta x, that added point where B lies, we are tending it to be 0. We are saying it is so small, delta x is 0. We are assuming it to be 0. But we cannot put as 0, otherwise we will get 0 by 0 form or something by 0 form. So when del x is 0, put it here, 2x plus del x. Del x 0, it will be 2x. Okay. So del x by del y by del x you cannot just write. You have to write del y by del x. Limit del x tends to 0. Okay. So we took 2 points. We try to find out a chord, and then we make it as a tangent. So y equals x square. This is how we got y is equal to x square. The differentiation is 2x. This 2x is called as a gradient function, and it is also called as a derived function of y equals x square, or simply you call it as the differential or differentiation. If you are using, say, function y equals fx, this fx can be log x, it can be a to the power x, it can be any function in mathematics. So the differentiation is f dash x, or the gradient or the slope, or m or dy by dx is f dash x. So x square is fx, f dash x will be 2x. So I'll just give you an example. You have a function y equals x square or fx equals x square. Now you need to find out the gradient at the point 5, 25. That is a point on the curve. How to find out? F dash x is what? 2x. Take the value of x, put it here. So 2 into 5 is going to be 10. This is your answer. This is your differentiation. Now if we have a point, we are just extending it to be more clear. If we have a point 3, 9 on this curve, y equals x square. Now B is a point very close to A. So we just add a delta x, very small. It can be assumed to be 0. So 3 we are adding just a delta x. And what will be the y? Because x is 3. So y will be what? 3 plus del x whole square. Because the function is y equals x square. So we will find out the gradient or the slope of the chord from A and B. there is a line. So y2 minus y1 by x2 minus x1 will be line. So del y by del x. Why we are writing del y del x? Because the distance we have assumed it to be very small. They are almost a and b are together. Okay. Because we want an instantaneous value, and that can be only found out using the tangent. So we have y2 minus y1 by x2 minus x1, that is this value which I just told you. So now a plus b whole square, you can open it using a square plus b square plus 2ab, and numerator 9 gets cancelled, denominator 3 gets cancelled. You can take a del x common from here, you just cancel it, 6 plus del x. So del x, finally you have to write 0. Del x limit tends to 0. Why? Because a and b are not different, they are one over another, they are one. Okay, that is how we find out the slope of, or the tan theta, or the dy by dx of that tangent which is passing through that particular point where we want it. 3 and 9. So the differentiation, or the del y by del x, limit del x tends to 0, is going to be 6. Remember, del y by del x, limit del x tends to 0 is simply dy by dx. This is dy by dx. So this is how we get the answer. I showed you using x and y, and now I showed you with an example. So this is how the first principle works. This is how the differential works.